Hello everyone, welcome to the NPTEL online certification course on fundamentals of food process engineering. We will discuss today mixing and agitation, and it is a continuation of our last class. In our last class and before that also we were discussing about mixing operation, mixing and agitation. We have by now completed introduction, mechanism of solid mixing, mixing index and mixing process, mixers for dry powders, and we have started in the last class the mixture of cohesive solid. So, we will continue with that today also, and first we will see that we have finished here where we were discussing about the kneader mixture. So, this is one kind of mixture that is used for the cohesive material, mixing of the cohesive material, and there are three different kind of blades as we can see that is used. One is sigma blade, another is the S type double nabbed fish tail blade, and the third C is the Z type disperser blade. Okay. Now, next is mixture extruder. So, here is the picture of a mixture extruder. So, mixture extruder in the sense that they are not only mixing, but extruding, that is also one operation that will be there, and here also there is a central shaft is there which is again grooved, and two blades are there. Okay. Two Z type blades are there. So, the discharge of continuous kneader is restricted by covering it with an extrusion die. Okay. So, we have fixed a die so that the otherwise the because of this motion the continuous discharge will takes place. So, by fixing a die we are restricting that movement. So, pressure is built by reducing the pitch of helix or by reducing the diameter of chamber or both. So, we can see that there is a pitch in the screw, that is the central screw. So, we can change the pitch. Okay. So, pitch is from one all the grooves are there. So, from okay. So, we are not having that color pen here, but anyway we will just inform you that if you see the grooves, different grooves are there. So, from one top of one screw, top of one rotation to the other top end, that whole length is called the pitch, and that pitch can be adjustable. It is you can change the screw in such a way so that the pitch will be lowered or higher, and because of that the pressure will build up. And also what we can do is we can reduce the size of the chamber as it is mentioned, or both the thing can be done, that is change of pitch as well as change of the chamber size, so that we can get the high pressure built in the inside of the chamber. Material is cut and folded and subjected to additional shear. So, because in the small zone along with that pressure development and the kneader blade will also move in the cohesive material. So, because of this special shape as we have mentioned in the Z shape blades, so they will cut and fold and shear it. Okay. So, additional force will be exerted on that. And heating jacket is also provided. So, because of all this action, that is a movement of the barrel, movement of the blades, there will be high pressure development. So, because of all that the heat energy will be generated. Okay. And that should be neutralized by circulating the chill water around the casing, and if you require some cooking effect to this, then we can use some heating jacket. Okay. So, in that case it will add some extra heat to the material, so that partial cooking will also be done along with the shearing or mixing action. So, then it is called the mixture extruder, because in extruder along with the mixing many operation happen, that is the shearing, kneading, mixing, cooking, and then finally the product will come out, their expansion or puffing, all things will be there. So, in such kind of a system thereby we provide the heating jacket as well, because in extrusion we generally need a very high temperature. Now, liquid mixing. So, here we have by now discussing about the solid mixing and the cohesive solid mixing. Okay. Now, next we will jump into the liquid mixing. So, the nature of the liquid mixing is totally different from what we have seen in the solid mixing, because also the power requirement in the liquid mixing is quite lesser than the solid or cohesive material mixing, and the mechanism is also very different. So, liquids are mixed usually by impellers. We have seen that in case of dry powder we have used the tumbler mixture, okay, or double cone mixtures, kind of that, horizontal mixture, barrel kind of mixture. Now, when we have seen the cohesive material, we have used blades, okay, because the high shear force is to be applied there. Now, for the liquid mixing we use the impellers. Okay. So, the impellers, those are mounted on a central shaft or a centrally mounted impellers are there in the tank or barrel where the liquid is kept. So, these are the liquid mixing. Liquids are mixed usually by impellers, which produces shear force for inducing the necessary flow pattern in the mixing container. So, now creating flow is a bit easy in the liquid, but what will be the direction of the flow, that matters in many times. Okay. Or if you are not mixing only two liquids, but there is a liquid and solid mixing, so then also what kind of flow pattern you are generating. So, that is important. Therefore, the impellers produces the shear forces for inducing the necessary flow pattern in the mixing container. Now, mixing occurs due to the resultant effect of three component acting on the liquid. One is the radial component, another is the tangential or circular component, and third is the axial or longitudinal component. Okay. So, component of what? Actually those impeller that is rotating. So, because of that the liquid will have a direction in all three ways, either radial direction or tangential direction or axial. Radial direction in the sense from the towards the barrel side to the inner side or the reverse, and tangential, that is the particle or the fluid element that is at the end of the impeller, that is being thrown in a tangential direction, or axial, that means along the impeller shaft they are moving. So, the vertical mixing will takes place. So, all such phenomena in many cases all three may happen or combination of them. Okay. So, the type of flow actually depends on the type of impeller that we are using, because not all the impellers will generate these three kind of different motions, there may be variations. So, that depends on the type of impeller that we are using, and also the characteristics of the fluid, that is whether it is a mixture of two different fluid of having different density, or these are of some a dispersion kind of material. Okay. So, what kind of material or what is the viscosity of the fluid, that is also important, what is the density of the fluid. So, the characteristics of the fluid is important parameter. Then the size proportion of the tank, baffle and impellers. Now, when we will see the geometry of this kind of a liquid mixing tank or barrel, we will see that there are some specific geometries are there. We use sometime baffles around the periphery, inner sides of the periphery, and this is used sometime to to restrict the vortex or create them, because the vortex will generate the proper mixing. So, because of that the baffles are used, and the impeller or the length of the impeller shaft. Okay. So, many parameters are there that will help or that will define what kind of flow will be generated in the liquid mixing case, whether it will be longitudinal or will be the radial flow or tangential flow, like that. Another thing is the size proportion. So, if suppose your impeller blade is not sufficient and they are only rotating central part, and the other part of the barrel the liquids are not initiated flow in them. So, they will be untouched. Okay. So, the zone the mixing will happen in the central zone only, in the bottom portion of the impeller, but not will be uniform mixing. So, the size proportion of the tank dia and impeller dia, also the impeller blade dimension, the baffle, everything is important, the height of the tank. Okay. So, all such parameters are important, and based on that we can define that what kind of flow regime is there, what kind of flow velocity is there, and how far it is affecting the mixing process in a particular liquid mixing. So, we will see first the radial component. Now, here we have the diagram where the top view and the side view is given. So, the outside white frame is signifying the barrel or the tank in which the baffles are attached. You can see a particular thickness of barrel is there, and centrally one shaft is mounted and the impeller is attached to it at the end, which is rotating at a particular speed, angular speed, and it has 4 impeller blades that we can see. Okay, 4 blades are there, and because these 4 blades are there and there are baffles, so it will create the small flow or vortex there, and this small flow, if you look into from the top view, that the direction of the liquid mixing is in the radial direction, from the center to the periphery and again periphery to the center. So, the flow pattern will be following the radial direction. So, these are the radial component. If the radial component of flow will exist, that will be shown by this kind of a pattern in a liquid mixing case. So, this acts in the direction perpendicular to the impeller shaft. Okay. So, these are acting perpendicular to the impeller shaft, and its effect will be excessive radial flow takes the material to the container wall, then the material falls to the bottom and rotates as a mass beneath to the impeller. Okay. So, if it is excessive, if the excessive radial flow takes place, then the condition will be like this, that the material falls to the bottom and rotates as a mass beneath the impeller. Now, tangential component if we see. So, for the tangential component, you can see the flow pattern will be like this. Here is a tank and there is an impeller which is at quite high from the bottom of the tank. Okay. And there are this impeller which is rotating, this is circulating the liquid in a tangential direction. So, if you see the top view, there are the motion of the liquid particle is in a tangential fashion. So, if it happens, then how it is going to affect the fluid mixing or flow pattern. So, this acts in the direction tangent to the or tangential to the circle of rotation around the impeller shaft. And if the shaft is placed vertically and centrally, tangential flow follows a circular path around the shaft and creates a vortex in the liquid. Okay. So, creation of the vortex will be beneficial because then the mixing will be good. Now, axial component when we see, so in this figure the blades are, this is kind of a carved blade we use, and this carved blade will initiate an axial or longitudinal flow. Okay. So, these are also called the propeller blade or carved blade are there. So, this acts in the direction parallel to the impeller shaft. So, this is the shaft and in the parallel direction the flow of the liquid will be there. So, it invert the liquid in the longitudinal direction. So, if the inadequate longitudinal component takes place, that will cause the liquid and solid to rotate in layers without mixing. So, that if this axial component of the mixing should be proper, particularly when it is a case of the solid and liquid mixture. Now, types of different agitator and impeller. So, there may be different kind of impeller or agitator, and that will be useful for a particular kind of liquid or liquid solid or different kind of mixtures. For example, paddle mixtures are there, propeller mixtures are there, turbine mixtures are there. Now, paddle agitator is looks like this, where the central shaft is there and the paddles are there, and these are having the there is no carved portion is there. These are simple and straight blade kind of agitators. This consists of a pair of flat blade mounted on a shaft. These paddles rotate at a low speed of 100 rpm. Okay. So, a pair of flat blade are there, that is called the paddle, and these rotates at a low speed, that is 100 rpm. They push the liquid radially and tangentially with almost no axial action. They push the liquid radially. So, if it rotate, so you can visualize that it will throw the liquid in a tangential direction, that is one, and some may be in the radial direction. So, no axial direction will be there unless the blades are pitched blade. Then in next case we will see that for the deep tank several paddles are attached one above the other on the same shaft. So, this is another mechanism, that in the same shaft if we use more number of paddles, if for a particular kind of large or very high tank, then they will be advantageous, and vortex formation is not possible with paddle impellers because of the low speed mixing, and disadvantage is that the mixing of the suspension is poor, therefore, the baffle tanks are required. Okay. So, types of agitator or impeller, if we see, this is another kind of, which is the anchor agitator. This is used for the high viscous fluid. These are anchor agitators. So, the blades are the shape of kind of an anchor, and it will since it surrounds the whole region, and it has high power of mixing. So, it is used for the high viscous fluid because it has a is a kind of a shearing and a blade. It will help in moving the viscous liquid because the thrust will be more because of the length of the blades. Okay. So, this is one kind of, and here we have seen that the vortex formation is not possible, that considered as an advantage, because if vortex formation will be there, the chances of the local mixing will be high, but uniform mixing will not be there in the whole chamber. Therefore, the vortex formation is prohibited by this mechanism. Now, next type of agitator or impeller is that turbine mixture. In turbine mixture, the impeller consist of a large number, that is 4 or more number of flat or carved blades. These are mounted on a usually vertical shaft. So, they exert considerable shear on the fluid and are therefore suitable in application involving mass transfer. So, because of this the carved blade, and they exert considerable shear on the fluid, okay, and therefore suitable for application involving the mass transfer, as for example, oxygen transfer in fermenters or phase dispersion, as for example, emulsification and homogenization. So, phase dispersion, that is emulsification and homogenization. So, in homogenization we also do another application along with this dispersion of the fat globules into the other liquid, that is the liquid milk. What it does is, it with mixing it reduces the size of the particle as well. So, that is why the difference in the homogenization is such that it initiate the particle mixing as well as the size reduction. Now, the diameter of the impeller is typically 1/3 to 1/2 of the diameter of the vessel or tank dia. So, with that 1/3 or 1/2 of the diameter we consider, especially in case of this turbine mixture. So, here the types of agitator or impeller given: carved blade turbine. This is also can be of many types. So, here this is the carved blade. This can be of flat as well as little carved section, and this is the disc turbine where the flat disc is there, in that the blades are attached, whereas in the carved blade turbine there is no disc portion is there, only with the shaft the carved blades are attached. So, these are the various kind of agitators or impeller. Now, another is the propeller kind of impellers. So, here is the picture how the propeller type agitator looks like. Okay. So, these are, as the picture is shown, it is kind of initiating the axial mixing of the liquid. So, primarily used to blend low viscosity liquids, and impeller diameter is much smaller than that of the turbine mixture, and the mixture shaft is usually positioned on an angle and off center, and the two are more propellers are used for deep tank. 2 or more propellers, that is in the same shaft more propellers we can use. This is the advantage is high mixing capacity, and disadvantage is not effective with liquid of viscosity higher than 5 Pascal second. So, for the low viscous sample only this propeller type of impellers are used. So, these are about different kind of impellers. We will stop here and we will continue in the next class. Thank you.